Today we are talking about an engineering speed run. We are going to go through this entire engineering design process in 1 to 2 days. So we learned about this engineering design process yesterday. You ask, identify the need and constraints. Constraints is a word that basically means like limitations. So is there anything that's limiting you? It could be money, it could be materials, it could be where you're doing it. So whatever the process is, there's probably going to be some limitations. Then research the problem. Then imagine, develop possible solutions, plan, select a promising solution, create, build a prototype. We talked about in this assignment already what a prototype is. But basically, a prototype is like a rough draft of your solution, of your design. Sometimes it's on like a small scale. So if you're doing like a building, you can't just build a building and see if it works and then make another one. You do a small scale, a small model of that building, and that would be your prototype. It's like your rough draft just to see if it works. Then test and evaluate that prototype, and then improve, redesign as needed. And most likely, you're going to go through this whole cycle a couple of times because once you realize, hey, I need to redesign, you have to go back to the beginning and see, hey, can I still solve this problem and do I still meet the limitations with my new idea? Research to see if there's any other new ideas you can think of to redesign. Then you actually have to redesign it. You have to pick your redesign plan, you have to create that redesign, and then test that redesign. And then you keep going and going until you get the thing that meets the problem, meets the need, and fits the limitations, and solves your problem. So, like I said, normally this would take anywhere from days to years, but we're going to try to do it in just 1 to 2 days. So, this is the assignment that you're clicking on the link under here for Paper Airplane Engineering Speed Run Day 1. For each step of the engineering design process, you will fill out the chart below. Make sure to watch the video in the assignment, or you can watch it here to help you with each step. This is the video that's right there, so good job, you found it. You have to ask, research, imagine and plan, create, test, and evaluate. And then there isn't the redesign portion yet. Redesigning will be tomorrow. So we're going to go through one entire prototype today and then redesign tomorrow. This first portion is already filled out for you, the ask, because we are going to tell you what your needs and constraints are. What is the problem? How to create a paper airplane that flies the farthest. So we're trying to find a paper airplane that goes a really long distance. What are the requirements? You can only use the materials specified, which will be right down below. It must be flown by you, meaning you have to be the one to chuck it. You can't ask your dad or mom or older sibling who has a really strong like baseball pitching arm to chuck it. It has to be you. And then you must be socially distant as you make and test them. This is especially for if you're doing this at school. If you're doing this at school and you're testing your paper airplane, make sure not to throw it at people, 1 for safety and 2 for social distance protocols. And then what materials can you use? 1 piece of paper for each prototype. You're going to be making more than 1 prototype because you're going to be designing, but only 1 piece of paper for each prototype. But you can use any kind of paper you want. So if you're at home right now and you have the ability to use different types of paper, go ahead and do that. You can use whatever paper you want. Now, research the problem. So research and investigate possible solutions. Use the links below for research and write down which ideas are the best below. In this empty space right here, you're going to write down all of your ideas. And you can use these 2 articles and these 3 videos. Or if you have something else that you can think of, another place where you know has really good paper airplane designs, you can go there. But these are the ones that we found that seem pretty decent. Write down all of your ideas here. It could be which article you like the best. It could be, oh, all the really good ones seem to have a certain wing size or have a certain length. Or there's ones where you know there's a common pattern because between the best designs. So you can say, oh, the best designs have really sharp tips or long or short wings. So not only which design you're following, but also you can do a combination and say which ones are the best. So especially if you find a couple designs that you really like, you can write down a couple of ideas. Next, imagine and plan. So you are going to be drawing your prototype, which is why you needed a pencil. So use your research to draw what your prototype would look like finished. Include measurements of the prototype dimensions. You can do this through Google Drawing or sketch it out on a piece of paper and upload a picture of it. I would highly suggest using a piece of paper, and you would do a prototype. So say that is my paper airplane design. This is what it'll look like when it's finished. I want to make sure I can get as many measurements as possible beforehand, because that's what would be on a real prototype. You would have a set of blueprints, and on that blueprint, you'd have to specify everything that you're doing. Today, we're just asking for the finished product and for measurements. So if I know that the piece of paper I'm using is an 8.5 by 11, which is the normal size of paper, then I can assume that length is going to be about 11 inches. But, of course, we're in science class. We don't do inches, we do centimeters. So, we're going to use the resources we have, 11 inches to centimeters. So 11 inches to centimeters, that is 27.94 centimeters. So on my drawing, my prototype design, if you can see that there, it says 27.94 centimeters. And if there's anything else I'm adding, so if I'm adding any wings on the side and I know that I really want to make them short, then I could even, instead of putting down a number, because I might not know the exact number, I can say short as possible. So that says, ooh, I don't know if you can read that, but it says short as possible, so I can also do an estimation if I want. I'm going to try my best to get the best prototype design that I can, and then I'm going to either screenshot it or take a picture of it and put it right here. And then next, create. So you're actually going to take your design and you are going to build it. You're going to take a picture with your webcam of your beautiful prototype that you have built and put that here. You don't need any measurements here, but you can if you want. And then test and evaluate. You'll be testing your prototype by throwing it down a long hallway or any open space you have at home. So for those at school, you guys are going to be throwing it down the long hallway outside the pod. Otherwise, if you're at home, if you have a hallway in your house, awesome. If you don't have an open space in your house, you can throw it outside, but keep in mind that wind might be a factor. So try to find more like a sheltered space so that the wind doesn't bother you too much. Once you have this tested, you are now going to evaluate it. So you're going to give me one piece of qualitative data. If you remember, qual or quality refers to words. You could be saying how far it went just in words. You could say, oh, it flew really high, it flew really low, it immediately went to the ground, it kind of zigzagged around. So you can kind of describe the flight path of your paper airplane. And then for a piece of quantitative data, I'm looking for numbers. So try to see if you can get how far it went. If you're in school, we have some tape measures marked out for you. If you're at home and you don't know how far it went, try to see if you can compare it to something. So if you're doing it in your hallway, you could say it went 3/4 of the way down the hallway. That's a number, 3/4. It went 3/4 of the way into the backyard. Even if you don't have specific measuring numbers, you can still use like an estimate to get your quantitative. And then you're going to give me some more evaluations. So what worked well? What didn't work? What changes need to be made? And then tomorrow, you're going to take the changes that you think need to be made and you're going to do day 2. Day 2 is going to be pretty similar to day 1, except you're going to be doing your redesigned prototype. So you're going to redesign it and do the same thing, and then you're going to do a conclusion based on what you've done. That is what you're doing today. If you have any questions, let me know, and happy flying. Bye.